Hello, welcome to Chapter 3. Before we get started, I want to clear up a couple things about Chapter 2, and then also about the course in general. We're skipping Chapter 2 for this course. Chapter 2 covers an overview of a lot of the things that you covered in CIS 141. So we're not going to spend too much time in this course doing a lecture on that. You are, however, going to be quizzed, judged on the contents of Chapter 2. Now, we're not going to do specific dates or anything from that chapter, but you do need to know what the components are of a computer system, hard drive, random access memory, read-only memory, all those things. So give that chapter a look, take some time to understand the readings from it. We'll refer to things covered in that chapter, but we're not going to do a lecture on it. Next, in terms of the quizzes, the Chapter 1 quiz and quizzes moving forward, it looks as if everyone fared okay with the Chapter 1 quiz. Looks like most of us were able to get in there, get it done in the time allocated. So that is a positive thing. We're in good shape there. Feeling very good about it. With that said, the quizzes at this point are not going to be multiple attempts. So you'll get one attempt at those quizzes now that you have seen them, now that you understand how it's going to work with Blackboard, and now that you know how much time you're going to have to complete those quizzes. So just going to be a one attempt going forward. All right, good. So let's talk about the contents of Chapter 3, which is database systems, data warehouses, and data marts. So we've got a lot of outcomes for this particular chapter. We're going to use the slide deck from the book. I changed the slide deck for Chapter 1. I was unhappy with the slide deck from the book, but I am comfortable with this slide deck. I think it really does distill down what's important very well. So let's dive right in. So we've got 5 learning outcomes that we want to, actually more than 5, I think it's about 8, I apologize. But we've got several learning outcomes that we want to make sure that we're communicating through reviewing this chapter. So the first 5 are on the screen. We want to define database and database management systems. And also there are a lot of terms within there that you need to make a part of your long-term memory. We want to explain how these things are designed. We want to know what is meaningful about a relationship or relational database model. We want to know the components of the systems of a data management system. We want to look at some recent trends in database design and use, maybe summarize them, and explain components of a data warehouse. Now, we're not just stopping there. Those are the 5 first ones. We have 3 more, and those are how to describe the functions of a data mart, look at business analytics and how this stuff actually makes meaningful business sense. And then we want to explain big data. And we actually want to first know what is big data, and then we want to know its role in business applications. So we've got a tall task ahead of us today. We want to make sure that we're covering each and every one of these things in a manner that at least piques your interest a little bit, in a way that's a little memorable so you can remember some of this, and something that reinforces the readings. Because again, what I'm covering is at a very top level, a very, what's the word? I'm hitting it quickly. The book will go more in depth. If this is stuff you're familiar with, hopefully hitting it from 2 sources will help it make meaning in your mind, all right? So let's just jump right into databases, all right? Now, a database, of course, is a collection of related data. We covered that in Chapter 1. We're going to look at data hierarchy. We're going to look at database management systems. And we're going to look at how databases work with users. And in this case, the user is not someone who is sitting at home with their pajamas on Facebook, but we're talking about business users, how we can use databases to really make business intelligence easier and more meaningful. So let's start with that interaction between the user and a database management system. You see you have the user over here on the left of the screen. The user makes a request for information. That request goes through a database management system. And it's interesting, this is the first layer that we interact with and the only layer that we interact with. Next, the database management system, it searches the database. When it is done, it sends it back to the database management system, which then returns data to the user. So you can see this user does not have any direct access to the database. This is not like opening up an Excel spreadsheet and diving right into the raw data. That's not the scenario we're talking about. What we're looking at is, as a user, we are interacting with a database system which has its own rules, its own models, its own file structures, all these things that are specific and designed just for it. And it is only going to allow us to do certain things based on its internal integrity rules. And this raw data is back here at the end, safe from user destruction, mistakes, or anything like that. Okay? So that's how the database interacts with us. We'll see these different components, the DBMS and the DB. We'll explain those a little bit further as we go in. And let's start with kind of the DB, the database. How is it structured? Well, there's a couple different ways. One is the sequential access file structure. Now, this is where the files or the records are organized in a way that is numerical, sequential, everything in its place. Now, this is a very common database file scheme. It's organized with a primary key, and you can think of the primary key as your WKU student ID. It's the one item of data that represents something bigger in the database. And now, to use an analogy for Excel, imagine if you had a list of students with their student names, their class number, their age, their GPA, what high school they went with. You had a spreadsheet in Excel with that. And each row had its own individual student on it. And the first column was the ID, but there were other columns going vertically across the page. Well, this is a good example of a table in one of these, in a simple database system. And the rows would be records, and the columns would be fields, and then the ID, the distinguishing characteristic, would be that WKU ID. So that's what this sequential access file structure kind of builds. And of course, databases are routinely backed up. They're used to archive, and with this sequential access structure, this is a real good methodology for that. Okay, now there's file structures, and then there's also types of data that's in a database. Now there are internal data and there are external data. Internal data is collected from within an organization, stored in the internal databases. External comes from places outside the organization. Now, there are certain places, there are data companies in the world that host just data for a lot of different people. So there could be a scenario where one database is located next to another database in the same building. But if they communicate and they're owned by different organizations, then that would be an external source of data, okay? And a lot of times it's stored, an external data is stored in a data warehouse. And we're gonna define this term as we go forward, okay? Another way to access files is random access file structure. And this is where files are put kind of on a tape drive, something for long-term backup, where the hardware itself does not lend itself to searching. It's just whatever comes off first is whatever you get. So, this is effective when it's a small number of records in a database where you can get all this information into the system quickly to be processed, or for long-term storage, like in magnetic tapes. And if, just to go back for a second, if magnetic tapes does not mean anything to you, if that's something that I'm saying and you're like, I don't know what this guy's talking about, I want you to take a look at chapter 2, because that means that you are kind of missing some of those core concepts that this course assumed that you had when you signed up. And chapter 2 is a good way to get a review on that. So there's a litmus test. If magnetic tapes doesn't mean anything to you, it sounds like a cassette deck, then take a look at chapter 2. All right. One last way we cover in this chapter about accessing files are index sequential access methods. So we talked about sequential access methods before, and here's another one. Just here's kind of an evolution on that, and it's an index sequential access method. So what are the difference? The records are both sequential or random, depending on how many are being accessed. So we kind of have the best of both worlds here. And it also uses an index structure that's separate from the primary key. So we have an index value, and then we have a pointer to the physical disk, or the physical hard drive in that database that tells you exactly where that record is. So this one's going to be a little bit faster in terms of giving you access to the data, getting the data back to you. So that's right now what we've talked about is how the files are physically, or how the files are stored on the physical media. Let's take a look at kind of the logical design of the database, not necessarily the files and how they're stored on the physical media. So to do this, we have to think about the database with two views, okay? There's the physical view, and that's what we just looked at. That's how the files are literally on the database hardware. Imagine if you could read magnetic ones and zeros. Well, if you looked at a disk, you would see them populate the hard drive itself. That would be the physical view. Now, the logical view is actually how we interact with the database management system, or interact with the database software. So that's the logical view. Now, the logical view it's different from the physical view in that it's software, but also how it appears. The logical view can be different from one individual user to the next. So if we think about the data, and we're an organization, we have customer data. Well, we may need the customer data for one logical view to show us customer patterns, how they like to shop, what they are interested in buying on a Labor Day weekend. Well, another logical view of the customer data could be a report that tells us how the customers are involved in invoicing and how they prefer to shop. So two different departments. One could be marketing research. The other could be system integrity and structuring user interfaces. They're looking at the same data, but they're looking at it from a different view. And that gives us the ability to really make some more better business intelligence. So that logical view is what we're going to take a look at now. Okay. So I was talking at an abstract level, kind of the user end, but the logical view even goes down to the actual software database design. So there's a couple things that are common among most database systems, and it is the data model. So the data model determines how the data is created, and it really is how do you structure the data in the system. It contains the data structure. It contains what operations we can do on the data. And then finally, it has some integrity rules. So if we look at these, the data structure is what data is either how data is connected to one another, how datums are connected to one another. The operations are, what are the things we can do to this data in a way that makes sense and that's predictable so that the computer system can handle these requests? And then finally, what rules do we have to make sure this is real data and that this data doesn't get corrupted by using some of these operations? So that's the data model. And then one model is a hierarchical model, okay? And this is kind of like, and here it refers to a tree. Think of it kind of like an organizational flow chart. And we'll take a look. So in this model, data items, and these are called nodes. So if we look, this is a node. This is a node here. I'm struggling with the PowerPoint this morning. So this is a node right here. This node has children. So it means it's a parent node. And these are the children of this parent node. And they call each other siblings, much like you call your siblings siblings. And the only reason you're siblings is because you have the same parents. And we can go down from one layer or generation of data to the next, okay? This model is how the relationships are built. So we know that the letter O is related to node P6. And this product 6 is a part of the third product line. And it is a product from supplier A. So what else do we know? Well, just given that, we know that Q, and we'll say this is a customer. Customer Q buys from supplier A. Customer C buys from supplier A, but customer C is only interested in product 1, but is not interested in product 2 or product 3. So we can also find some other things out here. Well, what if there's another supplier with this same product offering? We could look at it based on this model and see if we could find this customer there and get some insights on whether or not they're purchasing from them or purchasing from us. So this structure is pretty clear cut. You can see that it gets from small to big and detailed at the bottom. Okay, and the other thing about this is that you can see that these siblings don't really communicate with one another. It's a parent-sibling relationship, but not a sibling-to-sibling relationship. In some instances, that's good, and others that may leave an opportunity to do things differently. So let's take a look at the next model, which is considered the network model, okay? And it's similar to the hierarchical model, but records are organized a little bit differently, and it includes multiple parent and multiple child nodes. So let's take a look at this. So here we have this first parent level again. This is the customer. And then we have invoices that belong to the customers. But then wait, we have another parent at the bottom. And this is how they pay. And you can see here that payment has its own child, its own children, 222 and 555. But these children are also children of other nodes, 3000 and 9000, customer 3000 and customer 9000. So in this model, we see that we have more connectivity. Now this one is not as easy to understand at a glance. It takes some processing, and but it probably allows for some more flexibility in building a logical view for the user to extract data and extract meaning. So this is why these different models matter. The model that you pick should meet what your priorities are for your database system. And that's kind of one of the big takeaways here, is that these systems are based on priorities of the usage of the data, not necessarily just what seems to be the best thing, the hottest cookie at the time that the database is created. Okay. So we want to look at another model, and this is the relational model. And this one can be structured kind of in many different ways. But this one uses a two-dimensional table of records. And that is what I was describing to you earlier, something that looks like an Excel sheet. You can think of a table as kind of like a little spreadsheet. And rows are records, columns are fields. Now, before we go on, we need to talk about a data dictionary. Now, a data dictionary, in essence, has all of the columns for this particular table or for the entire database laid out so everyone can say, all right, the second column, table student, the first column is going to be a number. So that's the type. The default value will be 800 something. And the validation rules will be that it has to start with 800 or 801. Otherwise, it doesn't. You can't put it into the table. Now, that is kind of the basic structure. That's the integrity rules. We move on a little bit and we see we need a primary key. So this is something to make sure that every one of those rows is different from the rows above it and below it. That, in this case, was the student ID. No one else has your student ID number. No one else ever will have your student ID number at Western Kentucky University. And then there's something called a foreign key. The primary key is, if we think in terms of scope, the primary key scope is to be the most important number in its one table. A foreign key, what this is a primary key from another table that is put into your table to help you link backwards, okay? And that helps you cross-reference. And the reason that we use kind of this foreign key is it allows us to put the database in what we call normal forms, okay? And it's actually normalizing it. And what normalizing data does, putting it in a normal form, is it lets us pull out the things that make the data inefficient. We don't want to store your age and your GPA in 5 or 6 different tables because it's impossible to update 5 or 6 different tables for 20,000 records in a short and quick amount of time. You know, we demand efficiency. When I click on TopNet, I want TopNet to work. And I want it to work quickly. I don't want TopNet to belabor about looking at a lot of different things to load my stuff up. So we normalize it. We ensure that the data that is in one table belongs to that table and that it matters. It's a part of kind of a related chunk of data. And then we go through different stages from first to 5th normal form. Now, I think the book only talks about 3rd normal form, but it goes up to 5. And we understand that. So then let's talk about how we get data back from these normalized relationship model tables. Well, what we use is a couple different commands. We have select, which selects a group of data, project and join, which you're going to have to read to understand, intersection, which does exactly what you think it is. It finds out where one group of data and another group of data kind of intersect, where their stuff is alike, and returns that. We've got a union, which joins tables together. And you know, unions are really interesting because this is where those foreign keys really show their worth. You know, with a union, you can say, give me all of the data from the purchases table and all of the data from the course data, and then join them together based on the student ID. And we can see what student in what class is buying what at the bookstore. Now, I don't know that those databases are connected in real life, but if they were, that would be something that someone who was interested in choosing textbooks to make sure they're available could use to find out what percentage of students are buying textbooks at the bookstore and what percentage are buying textbooks and not buying textbooks to do digital means. So unions, you know, really putting that stuff together. And difference is something you can look in the reading. So you can see that we have a good set of tools to pick and combine data from different tables in this relationship model. And when we drop that in to kind of the components of a database management system, we can see that we've got we've got an engine to run it. We've got a definition that tells us the data. We know how to manipulate it, and application and administration we haven't talked about. But you can see how this is beginning to come together, how the database is a part of that 4-step process we talked in chapter 1, which is data, database, process, and then that makes information, and information is used for business intelligence. So we can already see that it's important to change this data into something meaningful, and that's what the database is doing. And then it's going to be the engine for kind of that processing. So let's jump right into a database engine. The database engine is the heart of the management system of the DBMS. It is how we can store data, manipulate it, and retrieve it. And this is software. Someone has sat down and written this piece of software that does this data manipulation for us. Now, it converts logical requests from users into their physical equivalents. What that means, in essence, is that you tell it something in a language, and we'll look at different languages that you want to do, and it will take care of making the hardware do those things. And it interacts with many different components of the DBMS. And to find out what those components are, do the reading. It's not a whole lot it's not hard, but it's something you need to understand. Next is a data definition. And this is pretty good because we can create a data dictionary. A data dictionary is not only good for the computer, but it's also good for the programmer or the DBMS, the user, to understand what data is available in the system. It is very difficult to decide what data you want to work with if you don't know what data is available. So this is why we need these data dictionaries, this data definition. It also lets us know how the files are structured in the database, and it allows us to make changes to the database structure in a very intelligent fashion. We talked about normal forms. If we want to make sure that the customer table is only housing data related to a customer, well, we need to have that data dictionary in our hand when we're going to add new fields. If we're talking about customer data and I want to add address, and then I also want to add product color, and then I want to add age, weight, and all these other things. Well, that product color doesn't fit there. And having a data dictionary available, or understanding the data model for that particular table, will let me know, hey, don't put that product thing there. Just fill out the rest of that customer data and put the product color information in the product table. That way it's very efficient and we're not bouncing back and forth for no reason. So that's kind of the data definition. Once we have the data defined, we can manipulate it. Now, we talked about CRUD earlier, and I think I may have got the acronym wrong. CRUD is create, read, update, and delete records. And that's what data manipulation is. It's adding, so that's creating. It's retrieving or reading. It's updating or modifying. And it's deleting records from a database. And that's what data manipulation is. That's all we do with the database. We either read what's in there, we add more, we update what's there, or we take out what we don't need anymore. But that is enough to really do everything we need to do in terms of getting that data to make sense. Now, there's two different ways to do it. One is query by example, and it involves kind of requesting data from a database, making a statement of questions. And the other one is structured query language, SQL. And you may have heard of this before you even started this course. And SQL is where you kind of type out the commands that you want to use to get data back and forth from the system. In the book, they do a really good job of talking about what you can do with these different languages. And I encourage you to look at it because My background is in computer science, and SQL is a very powerful way to get meaning from a group of data, or to really zero in on datums that are important to you. So, this is very powerful and kind of very exciting stuff. So I encourage you to research this a little bit more, SQL. And if you're thinking about maybe being a database administrator, your life will probably be spent a good amount of it using SQL. There may be some QBE there, but SQL is very popular. Now, we've talked about the database design, the data definitions, the data models, and how we use those to manipulate the data. Well, let's talk about how we generate applications to make this stuff usable by professionals. And that's exactly what it is, application generation. And this is where we take those lower level things that we just mentioned and we wrap them up in something a little bit at a higher level, which is something that is user friendly. It has screens or visual a user interface to let us know how to put data in. We can interact with it, and it also interfaces all of the other programming languages and opportunities together. So this is kind of at the database administrator level, okay? And to talk about database administration, let's dig into it. And what does this database administration look like? Well, first we're talking about keeping the data safe. So doing backups and recoveries, having security built into the database administration, and even making sure that we can manage change in the system, putting in more hardware, taking out hardware, all that stuff. It's used to determine who has the permission to do those functions we just mentioned, CRUD, creating, reading, updating, and deleting data. And just to give you an example of who has permission, when I log into TopNet, I have 3 panes that show up. Now, I think most of you all have kind of the student pane, or a big window. As soon as you log in, it says student window and tells you things that are important to students. When I log in, I have one that says student pane. Then that's 1/3 of the screen. The next 1/3 of the screen is the employer pane, because WKU employs me, so they're my boss. And then there's also another pane that says faculty, which says, hey, get your grades up. You need to get your stuff going. So database administrators, they're making these decisions. They're deciding, how the database is designed, its management. They're deciding who has rights, security rights. What can they do in the system? They're deciding how do they make sure that if there is a power loss, they can keep the system going. How can they recover data when it's lost or corrupted? They're fine-tuning it for efficiency. And this is where, to me, it's very similar to car racing. Because if you think about the normal forms, the thing we're doing, we were taking off stuff that you didn't need, making the database lighter. And that's what you do in NASCAR or Formula One. They are constantly removing weight from the vehicles so they can go faster around the track, so they can be more responsive, so they can fulfill the request, translating a movement in the steering wheel to actually moving the car in one direction to another. So this performance piece is a part of database administration and fine-tuning functions. And I think we just talked about fine-tuning. So that's the administration piece. And then the last end is the real user interface. And that's what I was talking about in TopNet. This is the data-driven portion, the website. This is where most of us will interact with it. So this is data-driven website, interfaces to a database that allows users to make data, to do this stuff remotely, and improves access to information. And finally, it gives users more current information. It's up to date. This is kind of right there on the spot data from the database. We're going to take a break and stop here. YouTube is much more friendly when I put up shorter videos. So we'll get into chapter 3, part 2 in just one moment.